Hello everyone. Some students have some question about this first question about parallel transistors. I know most of you are computer science majors. You may or may not have electrical circuits background, but that's okay. But this we only have a model of parallel transistors. But if you have ever learned a little bit circuit theory of transistors, this is really simple. You don't really need to understand that, but we just have a model. But nevertheless, I happen to have the background about electrical circuits. Let's just explain what actually happens. Um, Here is what in electrical circuits is a model of transistors. It's a semiconductor. It has three ends, and then here is the base. In one model, if the base voltage is high, we will count as 1, and this will be passed. Current will pass this way, and this light bulb will be lights up. But when the voltage over here is low, we mathematicians count as 0, and then that will be um, high resistance, which means that there will be no current. But electrically, it's equivalent to this, the circuits. If you ever have never learned the circuit theory, Ohm's law, they're equivalent to 2 resistors. This light bulb equivalent to 1 resistor, and here the transistor electrically equivalent to another resistor. Okay, in this, you parallel these resistors together. Um, Based on Ohm's law, they share the voltages. So normally, if this resistance, the transistor, equivalent to a very high resistance. So if it's low voltage, there will be high resistance. So the most voltage will be here. So if high voltage, high resistance is 0, is input here, and there's high voltage, and then most will be, it will be, this part will be high voltage, which means, and if you have low voltage, high voltage here, okay, which means high voltage here, and this equivalent to shorten the circuits, which means that is simply connected, bypass this, and then that will be low, most of the power will be on here. So then if you have 1, this will be low. So basically this is connected to the ground. So that is the equivalency of the transistor to a resistor that's controllable resistor. And further down, it is equivalent to here on this side, equivalent to simply a switch. We as mathematicians, we just think about this model is like, here is one. Open means infinitely high resistance. Okay, close means 0 resistance. So the B is either 0 or 1. In other words, if this is 1, this is closed, which means and this will be low. If it is 0, this will be open. So now here, I think you got it already. So 0 means open. Okay, 1 means close, like this. Close, then of course it pass. So now you probably see that. And then back to our question here, we ignore the electrical engineering details. So what we have here is that control. So 1 will be control. In fact, we missed one of the part. The power should not be here. The power there should be another resistor here. But in any case, in this part, if this is 1, it will be closed. But when that is closed, but this is whenever this is closed, and then that will be current go over here. As long as the 1 is closed, this will be low. Okay, so only when 3 are open, this will be high. So these are like 3 transistors in parallel, but this is our mathematical model. If you think about it, it's a model of the transistors. It's not an actual transistor implemented. In other words, this circuit's equivalent to a controllable switch. Okay, and this, but only thing we're sort of missing is we should have put like this. It should be these circuits, and there is actually a resistor here. a resistor here, and actually over here that's the voltage here, and actually power is actually over here. So that is somehow omitted. I apologize that, but that I apologize. So that is when that is the resistor here. The power is not actually here. It's actually here after resistor. We still consider this point, but the result is the same. If you see in this case, okay, these three is like a parallel resistors, okay, and but 3 open is the infinitely high resistance. Close is the zero resistance. That's our mathematician's model for this transistor. Simply become 0, 1 switches, 3 in parallel. Just to give you the answer for this one. So if any one is closed, okay, and this will be low. This will be connected to 0. So the electric current will go from here to here. Anyone is closed, it will be 0. Okay, only when 3 ones are open, okay, 0, 0, 0 for A, B, C, okay, and A, B, and C. Only when all 3 are open, like this case, this will be equivalent to a high resistance. 3 high resistance, then this will be high. So then output will be 1. The other cases are 0. Alright, so hope this is helpful. And once again, to summarize, the IQ transistors is this, and actually this is equivalent to 2 of the resistors. And one of the resistors is controllable by this input switch. And then we as mathematicians or computer scientists, we just model this like a 0-1 gate, sort of like this. Okay, we ignore all the, certainly ignore all the details, but we should have put a resistors here. Okay, that's the power. Okay, hope this is helpful. You have good evening. Okay.